Okay, so I had a little bit of a think about the last question that I worked through, and I thought, I wonder if there's an easier way. Could I try and break it down without doing all of the rearrangement of expressions and all of those ugly square roots? So, what I thought I would do is have another crack at this problem, and I found another way that some of you might like, and I'm going to work through that now. So the ideas are all the same what we previously spoke about. We have the area of a circle is increasing at a rate of 4 centimeters per second. So the first thing I can straight away say is I've got an area and it is per seconds. So I can write the change in area with respect to time is equal to 4 centimeters per second. So we've got a piece of information that's given to me straight away. The next thing, it has the question, at what rate is the circumference increasing? So if they don't specify, we always want that in relation to time. So we need to find the change in circumference with respect to time. And then finally, we have this point. We want to work it out when the radius is equal to 8. And that last part of substitution usually comes at the end of the problem. So I'm going to leave that till the very end. All right, so now let's work with what I've got. This is what I'm finding. I'm finding dc dt. I already know what dA dt is. So to cancel out that dA on the top, I need to multiply by a dA on the bottom. And I've already got my dt on the bottom, so to get a dc on the top, I need to put a dc on the top. So a change in circumference with respect to time. So then I get to this point, it's like, right, I've got to work out what is dc dA. I know these other parts. This, as I mentioned, is what I want to find. This is what I was given. Now I've got to work out how I'm going to get this rate here. All right, so what do I know about the problem? Okay, it uses the area of a circle. It talks about the circumference. So what do I know about the area of a circle? All right, I know the area of a circle is pi r squared. Cool, I could differentiate this and I would get dA dr equals 2 pi r. All right, nice, but I don't need dA dr. This is not a derivative that is useful for me because I want to have dc dA. All right, what else do I know about a circle? All right, I know the circumference is 2 pi r. All right, I could differentiate that. dc dr equals 2 pi. Cool, but again, I don't want dc dr. I'm trying to find out what dc dA is. What can I do with that information? All right, well, rather than doing the rearrangement that I did in the last video, why don't I put these two expressions together? I'm trying to find out the derivative or the rate that is dc dA. And if I want to find dc dA, well, I could do dc dr times by dr dA. So I can put these two expressions together here and put them into their own little chain rule to cancel out the r's and get my dc dA. So oops, that's the wrong tool. So dc dr is equal to 2 pi. Is equal to 2 pi. And dr dt, well, I've got to flip this one upside down, becomes 1 over 2 pi r. All right. So then my 2 pi and my 2 pi cancel out, and I get dc dA equals 1 on r. Okay, substitute that into my expression here. Substitute the 4 centimeters into the expression here, and I get dc dt is equal to 4 times 1 on r. And then, as I mentioned, this little part at the end, when the radius is 8, we usually wait and leave the substitution till the end. I'm going to put that into my expression now. 4 times 1 on 8, which equals a half. And this is my change in circumference with respect to time. Now, it's a measurement problem. We always stick our units in. So circumference is in centimeters and time is in seconds. So my rate would be 1/2 centimeter per second. So there's a variation, probably a lot quicker, a little less complicated, but certainly some more thinking about how you can